starting temperatures in the afternoon.
Also, I don't know if
yeah, after this whole moderation goes live right now.
All right, so how's that sound? Do you notice any echo?
a little bit.
Okay, we're about to get started. Want me to keep talking? Okay, yeah. Yeah, what? Yeah, I know, it's a kind of strange, yeah, to have a microphone. But you know, the room now, we have all these air filters and whatnot
in this room, so we got to try and get over the sound.
Plus
Plus
the
the
elves
elves
who
who
are
are banging around on the pipes in this room. That's historic. We can't get rid of them even with a renovation.
So,
I'm going to say go ahead.
okay, I think we're ready to go. Well, welcome to our first weather watch of the 2025-26 academic year. We will do this, if you don't know, every Friday at 12:15. In fact, this semester will start at 12:15. There's a class that leaves here at 11:50, and that 25 minutes gives us time to get ourselves set up. And we'll see just how well or how unwell that setup
went today.
But that'll be the time, 12:15. And we go for about an hour. So, but it's informal, so I see Sam's eating his lunch, he knows the rules. I'm not pointing you out, Sam. Actually, yes, I am. But not for any bad reason. It's informal. You don't need to worry about, you know, coming in and putting your hand up when you want to make a comment. You just try and get the attention of the people who are speaking. And it's a conversation about the current weather, maybe the days leading up to the current weather, and then usually a forecast. And invariably, an argument of one kind or another breaks out, sometimes of substance, and most other times of absolutely no substance. But and then Michael and I are rather famous for that. But it's just because that's the nature of not only our interaction, our science, the nature of doing science, but the nature of this department. For those of you who are new here, you're going to enjoy that, I think. So.
And also, in addition to past week's weather, current weather, future weather, we also have a new component from the state climatologist's office. We're going to have
That's correct.
A climate update from time to time. So.
Which is great. And, you know, Steve Avris, who's now leading the office, requested once a month, and we kind of both said, no, as frequently as you need. That'll be fun for us to involve that. So it's actually looking now at the past, wondering why this was never formally the case to begin with. But I'm glad it is now. Before I start, I will honor the absence of Patrick Beatty, who really carried water for this discussion for a long, long time in the last several years and did an excellent job at it. But now he's off to greener pastures and enjoying himself down in Florida and working hard. So we do miss you, Patrick, but we thank you for the many years of your service in this enterprise, and it was really well done. So what we're looking at here is not quite a week long. I stopped it at the beginning of September because for a couple of reasons. One is some of the stuff that I'll talk about, current weather and things leading up to the day, I really want to show you just from September 1. And so I'm trying to show you just the satellite images from that. We're going to see an invasion from high latitudes in various other variables. And you know what happened. We had a nice cool down, dew points dropped, the temperatures were low. We had a 43-degree temperature at the airport yesterday morning, which is really cold, approaching the all-time record for the date. We missed it only by 8 degrees. And when you get to 35 on the 4th of September, that's an extraordinarily low temperature. So we were in the neighborhood of extraordinary, but not quite as intense. But that invasion led to the development of primary cyclone 1, and then you'll see, and we'll investigate the evolution of secondary cyclone. They were very, very different in a lot of the characteristics, and this is an initial analysis that I'll show you some things about. One of them was an upper sort of an isotropic vortex that was the first cold snap, and then immediately following it was one that formed as a result of an upper frontogenesis process, so a much more linear structure at the tropopause or below the tropopause. Totally different, and some of the aspects of the weather and the ways in which they developed are also different as a consequence. I think one thing I pointed out to Michael this week, look at this stratocumulus over western Ontario and parts of Manitoba. We'll get back to it again. It looked very much like the kind of stratocumulus you have in a cold air outbreak over water, either the ocean or one of the lakes. And I thought, boy, that's weird. That has to be at a time when there's vegetation still evapotranspiring. Because look at right there. Doesn't it look like the same thing we'll see later on in the stratocumulus off the coast? So somewhat unusual, I think, testifying to the extreme nature of the cold air that's associated with this event and has really chilled us down. Libby was telling me she likes to sleep with the windows open in her house. Couldn't do it the other night. It's too cold probably a lot of you felt the same way. I did too. I immediately agreed. Okay, so storm number 1 takes on the complexion of like a Hudson Bay low, and then you'll see, I'll show you one more time before we go to some other variables to look at. I want to show you what comes in that second round. So here's the first kind of boundary, cold frontal boundary, and it's a part of a cyclogenesis event. And then there's a second one that comes in, and you'll see it kind of show right across the state and kind of gets itself involved in this much broader, enlarging cyclone that, as I say, ends up sitting over Hudson Bay. So it's early for this sort of Hudson Bay feature to appear. It's probably going to be transient because it's so early, but I'll show you also how anomalous this is from Alicia Bentley's standardized anomaly maps, which are very handy in that regard. So I focused entirely on the weather over Ontario and the Great Lakes states and our own region. There's quite a bit, well, not quite a bit. There's something going on in the tropics. Most of the tropical action in terms of organized cyclones is in the Pacific. I forget what the names of these two. One of them is Kiko or something. I think it's on its way to Hawaii. And then there was another one with an L back behind it, Lorena, that is kind of getting itself organized in the far eastern Pacific. That's probably this complex. I don't know where the center of the disturbance is, and I did not look at that because I had a visitor today who took some of my time, which was fine. And nothing particularly well organized in the Atlantic, and we're into September 4th. The climatological peak of the Atlantic hurricane season is a week away, and not much has happened this year. Now, I'm not about to start one of our stupid arguments, but I will point out that usually we've had a little bit of activity by this time. And I will point this out. We've had some really substantial extratropical cyclone activity over us already for this season. So we're waiting for the Atlantic to brew up. I don't know what the most recent statement from Colorado State is about what the expectation is for the season, but I think it was diminished from their original one. I don't know by how much.
But NOAA's continued to say above normal.
Oh, is that right? Okay, so above normal. So the best is yet to come, and I suppose, and undeniably, or I shouldn't say undeniably because I don't know, but most likely relatively warm waters. They haven't been raked by any organized systems, and it's been a warm summer. So I think combination could mean September and October could be of interest in the Atlantic basin. Okay, can we go, Pete? Let me talk a little bit about this cold snap we had. Just a couple of facts. We don't have to go anywhere to show it. But as far as I could determine this morning, the coldest September 4th for daily average temperature was in 1974 when the temperature was 61 degrees. Now, on this site that I was looking at is usually updated right up to the minute. So for some reason, our 53 for yesterday, we had a 63 for a high and 43 for a low. So our average was 53, is well below that record for the 4th of September, and it wasn't listed. So maybe there's something lost in translation or some of the data has not gotten to the right places yet. But as I mentioned, 43 was the low for yesterday morning, and that's only 8 degrees shy of the all-time record, which is 35. So I don't know if we've broken a record, but we've been in the neighborhood of a record with this cold snap, and that's kind of of some interest. If we can go to my laptop for a minute. September 1 also happens to be the day that I start keeping track of the cold pool. So the area of temperatures colder than minus 5 degrees C at 850 millibars. So this map has a little bit too much on it, but I'll try and explain what it is. First, the dark brown line is the actual 12Z this morning position of the minus 5 isotherm at 850 millibars. So there's two lobes. There's one over in the eastern hemisphere and this one pretty much over Greenland and the Labrador Sea. And they're separated. The green dashed line is the average position over the last, I think, 68 years or something of the minus 5 isotherm at this particular moment, 12Z on the 5th of September. So you can see there's some places where we're colder than normal, up here in the sort of the north of Kamchatka, north of the North Slope. And then there are places where we're a lot warmer than normal. So most of central Canada, the archipelago, is a lot warmer than normal. And Labrador Sea is colder than usual, and so on. Overall, this is slightly lower than average across the whole hemisphere, as it turns out. And that seems to be, there's two things that might strike you as funny about this. First of all, here we are in Madison, and we're talking about a cold spell. It doesn't involve temperatures at minus 5 at 850 millibars. So, but nonetheless, it's chillier than normal here, and you'll see a couple of representations of that in a few minutes. And yet, northern hemisphere-wise, we are not off to any sort of a great start for cold air. We're well below the average, in fact.
So, John, does that suggest that the cold air of Russ is rather shallow?
It does, and you'll see that in a couple of things. I don't particularly highlight that, but you can't miss it on a couple of the cross sections I'll show you. It's very shallow. So one imagines that, there's some depth to this cold dome, and then you just get this flat pancake sort of structure that barely hovers over the ground, and that's probably about right over much of the rest of the region. So that's of interest. And then here's the next slide on this, Pete, if you can just click to the next one with an arrow button. This is the actual time series that we're beginning to evolve. I'll point out what I have here. The long-term, the longest average here is the blue line. That's 1948 to 2014. The black line is the first 30 years of that, approximately, and the green line is the last 30 years of that. So the climatology hasn't changed that much between black and green over that period of time. And then the all-time maximum or minimum aerial extent for each day is indicated by the green lines, the gray lines. Top is the maximum, of course, and the bottom of the gray line is the minimum. And there's our time series through September 4th. So we're below the average, no matter how you calculate it, by the time we get to the 3rd and 4th of September of this year. Last year, it was the warmest September, October, November of all time by this measure. So we're off to some start. I don't put any stock in what's going on yet, but it's interesting that we're cooler than normal. And if I were in front of a U.S. Senate panel testifying to what's happening to the climate, I'd have to say we're warmer than normal. And 50 of those heads would explode, and you know which ones. So anyway, but it's true. There's the observations for it.
So John, I'm just curious. Every time I see this, new questions come up.
Yeah.
Is there a difference between the aerial average at 0Z versus 12Z? Are there any fluctuations from?
That's a good question. I don't know. I doubt it, because one half of the world at 0Z is different from the other half of the world at 12Z and vice versa. So I don't know if that's, if there's anything to that. And I've never stratified the data that way, but it wouldn't be that hard to do so. It'd be kind of fun to try that out. But that's the beauty of looking at the whole hemisphere at once, is that you don't have to think about those things as a first-order problem, but it's as a secondary, interesting problem. Okay, can we take a look now? Thank you, Pete, for this. We'll go back to our regular maps. Keep an eye on the clock here. Can we go to our regular super Petes? No, not that. We'll take a close-up view of what we have in the visible instead of this right now. So here's our current last 4 or 5 or so hours. So here's the center of the circulation up in northern Ontario from this major cyclone that by this time, as you'll see when we go through some more analysis, by this time has become the amalgamation of the primary cyclone that came through on Tuesday night and Wednesday, and then the secondary one that kind of came in the northwesterly flow, took on a little bit better shape as it came across the lakes and added to this whole circulation. So this is, as I say, something like a Hudson Bay type disturbance. The scale is enormous, and it's involving some of the coldest air we've seen all season long, and that's really welcome because our summer was unrelentingly humid, at least. I think I've got a young person who's I'm meeting with next week. I haven't met him yet. We're going to be talking about maybe theta E at 12Z or at 18Z over the whole summer and just seeing what the time series looks like and comparing it to historical records. I have a feeling this summer's daily time series of 18Z theta E would challenge just about any summer that's come before it. Maybe 1988 would stand out by virtue of the high temperatures. I forget, I didn't live here at the time, what the humidity was like. My feeling here is that we had dew points over 65 on a larger number of days this year than I can remember in the 31, 35 years I've lived here, however long. So anyway, this is a welcome relief from that. And you can see that not much of what was going on in the tropical Atlantic manifests itself as anything organized in the visible. Sometimes the infrared can give you a little bit of a misrepresentation of what's actually underneath the cirrus hood, and I think that's probably largely the case over this part of the world. Maybe even so over parts of the Pacific Basin. That looks like Lorena, probably the center of the circulation of that disturbance. Okay, so that's what, and cold air coming across the Labrador Sea. Here's the stratocumulus that you often get in such things, and doesn't that look a lot like what we had over parts of the border with Canada? So really interesting how that's the case. Maybe it's seasonal. You don't see that any other season except right now. I don't know. It never caught my attention like it did this week. Okay, can we go to our super Petes? First, the radar, Pete. Let's see where.
Patrick is online and watching, so he's with us in spirit.
Oh, great. All right, that's great. That means he's not doing his work in Florida either. And that has nothing to do with the training he received under me.
We're looking at radar.
Yeah. Okay, so here's our radar, and you can see nothing looks particularly well organized. That will change in the forecast. We're going to end up with, I'm going to give up all the story, but we'll end up, for reasons that I think I can describe, maybe I'll be left to the forecast, a nice line of showers will develop around from, sort of northern New England down to about St. Louis. And you get a sense that there's maybe some available moisture ready for some sort of structure and dynamics to come along and ingest it, and that is actually, it turns out to be true. Scattered precipitation, not well organized over the Panhandle and the Bahamas, and then a little bit over Arizona. That seems interesting, doesn't it? And some showers on the Washington-Oregon border. But really, that's about it across the country at this moment, in the last hours surrounding this moment. So pretty nice day across the country in terms of the precipitation. And let's take a look now at our super peats. Let's start at 300 millibars, if we could, Pete. For those who don't know, Pete is our invaluable technical and computer guy, and so he makes these maps for us. And there's 3 different sizes. Some are just the continental U.S., one's a little bit bigger than that, and this is almost all of North America and adjacent waters, so we call it the Super Pete, because it's super sized and made by Pete. So here's our, there's a lot of new people here on the first day. I want to make sure they know what's going on. So here's the 12Z, 7 a.m. local time analysis from 300 millibars. Pete pointed out to me a whole bunch of normal sounding stations do not show up on these maps. And the way that you can see their absence, it's not so easy on a single map, but if you look at animations, which Pete also makes of these maps for like a whole week, you can really see them. They're spotty. So that's part of the waste, fraud, and abuse that's been miraculously captured by our government. And we don't want to be wasting money on soundings that will inform us about what the weather might be like. That would be a waste of time and money. So here's a deep trough that's cut itself out over the central part of North America, I'll say, not just the United States, but also Canada. And we're not going to go backwards on these maps to find this out, but you could have seen, if you looked earlier in the week, September 1st, August 31, you had most of your jet right about here over the archipelago and northern part of some of the prairie provinces. Very, very different from now. We've carved out some enormous upper trough in a climatologically wintertime spot with a pretty intense jet just south of the border with us, or just across us, right at the border of Illinois and Wisconsin. So the wind speeds here in the 130 knot range in Michigan. And it's 90 knots at Green Bay at 300 millibars, and 100 down here southeast of Des Moines.
John?
Yeah.
People are talking about this maybe being the first polar vortex outbreak. Is there a polar vortex yet to associate?
That is a really good question. I think no. I think this is a cross current of the now recently described polar vortex as cold air masses in the lower troposphere, and the actual polar vortex was the establishment of the stratospheric polar vortex. My guess is, Brad, seeing those the double lobes of 850 cold means that there's nothing well organized yet at that altitude or at those latitudes. So this is just an excursion of cold air that's brought in the form of an upper vortex. But we'll see that. But it's not the so-called polar vortex. That's a good question. So here's the upper jet. And if you look at if you only had this map, you'd say, well, I guess I understand the development over Ontario. It's in the left exit broadly of this jet. This jet maybe come down in northwesterly flow, and it's kind of rounded the base of the trough. Some elements of that argument are true, but it's more interesting than that because there's 2 separate features that inform this development to the point where it got to at this stage. And I'll show you that if time allows. Can we go to 500 millibars, Pete? Where we should see roughly the same structure but less intense winds. And we do. We see a cutoff low over central Ontario. Center of that, the temperature is minus 26.5 in the analysis today. That's cold. I mean, you don't get colder than minus 45 in the depths of the winter at 500 millibars at these latitudes. And so we're getting pretty darn close to what you'd have to call a polar outbreak. But it's not associated with the actual stratospheric polar vortex. But look at over here. Here's a secondary cold pool over North Dakota, parts of South Dakota, almost as cold, but obviously separate, because in between at International Falls, it's minus 19. So this is a separate lobe of cold air. That also seems to have its own little short wave associated with it. And so this feature here is second of the broad waves that have been involved in creating this upper trough. So this feature is something of interest. And it gives one the impression that you really have to think about maybe more than one shortwave feature in the evolution of this whole weather system. Upstream, there's a nearly north-south ridge, and downstream of the ridge axis, of course, there's straight northerly flow. And I'll just point something out to you about this, because it has something to do with how the second feature developed. When you have a ridge like this, strongly curved like it is, the flow at the ridge crest is strongly supergeostrophic. And the flow at the trough axis to the east is strongly subgeostrophic. So somewhere in between there's a lot of convergence. And it turns out it's not all the same everywhere along there. So the subsidence induced by that pairing of super and subgeostrophic flow actually increases as you move southward towards the trough axis. So there's a variable amount of subsidence here. If you had an isentrope like this, as one of a bundle, and you have more sinking down here than you do here, you're going to make this air warmer differentially compared to that. And that's going to tilt the isentropes this way. And this is an idea by Rich Rotuno and colleagues that helps to understand why in northerly or northwesterly flow that ever-increasing subsidence acts to rotate the isentropes independent of the isohypses to produce cold advection and cyclonic shear. That really gets the upper frontogenesis process going. So it has to do with the broad structure of the trough ridge coupling, not so much what's going on in the straight northerly flow. But the differential subsidence along the flow tilts the isentropes this way into horizontal. And son of a gun, that helps to instigate cold advection and cyclonic shear, which for reasons that we won't have time to describe today, but we'll talk about it a lot this fall, that ends up helping to develop upper vortex structures. And that's where all of our vorticity at upper levels for development at the surface comes from. So that we'll keep an eye on that with Vis 5D if we have time. Let's go to 850. We'll skip 700 today in the interest of time. At 850, we really want to see where is it cold. It's -4 in central Ontario, so it's almost as cold as -5, but not quite. And so here you can see the baroclinicity is fairly intense. The front edge of it probably now is down near the Boot Heel of Missouri. And so they're finally getting cold advection at Joplin, for instance, and cold advection in central Illinois, probably also here in southeastern Ohio for the first time. That's the first time they've really felt that relief. And we've been long into the cold advection. Now we're looking at 1 degree above zero at 850 at Minneapolis. It's +2 at Green Bay. Continued northwesterly flow, -1 at International Falls. So cold advection continues to funnel in over us. Probably the explanation for the increase in the stratocumulus that we've seen as the days worn on. We started out nice and sunny, daytime heating, stability goes down, and there's enough water vapor around that you can create this kind of low cloud deck. And that's a function of cold advection and daytime heating destabilizing the lapse rate. And so that's kind of an interesting fall-like event for today. But look at this really intense upper feature that's sitting over just south of Hudson Bay. I mean, it's absolutely huge and very well organized. And this is the result of about 4 days of evolution. So I want to show you that in the next couple of minutes, okay? Can we go to Alicia's maps, Pete? I have that on as one of the tabs, and I think I set it up the way that I wanted. It's, yeah, right here. Yeah, so here's the 500 millibar relative vorticity at 0Z on the 1st of September. I don't really care about the vorticity so much as I do the geopotential height, which is in solid black. And the blue speckling is vertical motion, and it's just, it gets in the way. It's confusing, so try to look through it. But here we are on the 1st of September, 0Z on the 1st of September. The Arctic vorticity structures are well north of, this is 60 degrees north, so they're well into the high latitudes. There's nothing going on over continental North America all the way up to the northern part of the prairie provinces. So it's broad, weak flow at 500 millibars. But these features are about to invade. So let's take a look. I think it's this one right here, in fact, that comes in over the part of the Northwest Territories that is primary feature number 1. So let's step forward. Keep your eye on this thing. Here it comes. And look at the isotherms in red. We'll stop there. They're kind of concentric. They were even more obviously so a minute or two ago. But they're pretty concentric, and so is the geopotential height cutoff. It's just sort of a isotropic, mostly circular disturbance. Let's keep going, Pete. Thanks. Here it comes, straight southward. Man, if this were January, you'd be thinking, it's going to get down to -20. So there's this really obvious upper level, but notice how it stays very circular. Keep on going. Stays circular all the way down to over us. So that's we'll stop there. Really intense isotropic disturbance that ends up residing right over the Upper Peninsula. And it's got its own isotropic cold feature in the middle. I think it's -20, this isotherm right here. So very, very cold. It hasn't gotten warmer as it moves southward. Maybe it's gotten a little bit colder, okay? So that was the one that by the time we got to Wednesday afternoon or Wednesday night, we were feeling the effect of that disturbance. We had a little bit of rain, I think, that night. We had the dew points went down, temperature went down. It was chilly already on Tuesday, but it was even worse on Wednesday. And so that was the effect of this disturbance. What I find interesting about it is that it stays so circular the whole time. This is dominated by curvature vorticity all the way through its lifetime, at least through when we experience it. Let's go back a few, Pete, and I'll just point out where the second disturbance comes from. And that one, if we go back one more time, it comes across the Alaska coast off the Bering Sea as a little trough right here. Notice this ridge axis is about to break, but softly break. I'd say it's sort of like falling onto a foam floor. And so it just breaks a little bit and becomes a flat sort of ridge. Watch where this thing goes as that happens. So there it kind of lost for a while, comes out, here it comes again, and there it comes. Now, stop there, Pete. This is -24 also. That's really cold, okay? And the flow is kind of straight northwesterly. There's beginning to be a little bit of cold advection and cyclonic shear. We'll go one more time. I think you'll see it more obviously. Right in here, right north of, right on the border of Alberta and Manitoba. You can see cold advection and cyclonic shear developing, pretty strong temperature contrast. Later on, we'll take a cross-section through that. This is a really nice upper front. And since it's a front, it has a vortex structure. And this vorticity that's associated with that baroclinicity is very different than this vorticity, which is kind of isotropic. This one is linear and frontal in nature. So that's storm number one that went by early in the morning on Wednesday. Let's keep going, Pete. And here comes the second disturbance. Notice how the vortex structure seems to start to get a little bit better organized. Cold advection intensifies. We'll go again. And then it's really looking intense. It's -24 right in the middle of that thing. And that's on our heels yesterday afternoon. And that's the thing that came through overnight, dropped the temperature again, and it was windy. We had pretty substantial winds. So Madison's right there. This is 6 p.m. last night. We are certainly in Madison down shear of a substantial upper vortex, not the primary one, but this secondary one that formed a northwesterly flow. Look at this horizontal temperature gradient that's been associated with that development. And so we have some ascent, broadly speaking, over the central part of the state. And one more time would get us, or two more times to get us to the morning. And now we have most of the ascent to our north and east, but we're firmly in the cold air again, and the clouds reflect that. So we'll keep going one or two more times, Pete. Storm number 2, storm number 1, and then you can't really make a distinction after a certain time. When you can't, it's about now, you have, or close to now, you have this really well-developed and seemingly stationary cold vortex at upper levels. So really neat.
Yeah, it's really interesting that over Iowa at this time, I guess it's a 0Z this evening.
Yeah.
That little vortex there, which came in also in the northwesterly flow,
Yeah.
begins to develop. But it's interesting, it's heading eastward toward an area of baroclinicity and some weak frontogenesis of the
Yeah,
surface.
right in here,
so
yeah.
it's probably going to be associated with some precipitation.
Yeah, and I'll bet you, I think we saw yesterday, and this was before this information, and I don't even know if this disturbance was in yesterday's progs, but to the extent that it wasn't, maybe now we're going to see that whole line of precipitation that develops in the frontogenetic region, which I won't have time to describe, you might. Maybe there'll be a little sprinkling of a little bit more intense frontogenesis. But this is a really good point, Michael, you're making. Here's yet another disturbance that emerges out of this northwesterly, northerly flow. Again, because there's a ridge axis and a trough axis in close proximity, there's a long flow gradient in subsidence, it's easy to start tilting the tropopause and creating these little vortex structures.
So just north of North Dakota and then further north, you can see two other sort of local maxima.
Yeah, there's one and there's one.
Right.
Yep.
Somewhere in the spacing of that, if it's just a nice vortex strip that's trying to roll up.
Yeah, it would be nice to, this is now a forecast, it'd be really nice to look at the water vapor channel late this afternoon. There might be like a string of pearls, these little swirlies connected seemingly in this region. I wouldn't doubt that at all. Yeah, that's a really good point. And each one of them is probably a manifestation of a little localized maximum in subsidence and a little bit of maximum in the PV as a consequence of that, because you're so close to this tropopause when you're at this height or above. Yeah, and then they all get thrown into this thing and they get amalgamated, and it takes a while for that vortex structure to dissipate. All it'll do for us, and you'll say probably in the forecast, it'll move away, and it might be replaced by something else at our stationary location. I think I wanted to just show a couple of things on Viz 5D. Do I have time to do that?
Yeah.
All right. And then we'll be done. So here is, again, starting on Monday, the 1st of September. What, wasn't that the first? Yeah, I think it was. This is theta E at 950 in green and sea level pressure in yellow. And so just to point out that at the beginning of the week, we were not anywhere near this polar air. It's well to the north. And you can see it in two gradients. One's very intense across the chain of lakes, and another one over Great Bear Lake is not so strong as that. So let's just go through a couple of these, Pete. We'll just step through them. I think they're every 6 hours, is that right? Yeah, every 6 hours. Takes a while for this whole baroclinic region to be mobilized, but here it comes. Now we're on Monday at noon, 7 a.m. Keep going. We'll go kind of quickly through this. Just because once you put your eye on this zone of baroclinicity, you can kind of see how it's marching southward. And here it comes. Begins to be a region of development, too. There's a little bit of development going on just north of Lake Superior. Let's keep going. And that becomes a pivot point for some of it. So to the west, that cold air starts to funnel in, chillier air. And again, it's 950 theta E. By this time, we're at midnight Tuesday, which is about when the transition was beginning to come on. First day of class was the next day. Let's keep going. And you can see here it comes swinging through at 950, and we felt the relief of that. And we'll keep on going. Look at this wide region of low theta E that has now been opened up by this whole structure. And so it's kind of made its way through the state of Wisconsin. We're not going to really see the secondary wave in these depictions, but we'll keep going anyway, see if we see anything interesting. I think we will. There's the beginning of a development of a thermal wave, and that's the one that's coming through. And so it's going to be a part of this whole big complex where the coldest air is kind of centered just north of Lake Superior. Let's go to 500 millibars instead. And let's see, I have the pressure and theta in this case. So here's 500 millibars. We should go back to the beginning. Oh, we have. Thanks, Pete. So very cold air at 500. The red are the isotropes every 3 degrees. And then pressure, since this is in height coordinates, pressure every 4 millibars. So you see, just like we saw on the original 500 millibar map in the Bentley series, no flow at all over the continental 48. All the flow is to the north. Let's just march forward rather quickly so we can save time for the forecast. So here comes wave number 1. We can stop there. We'll go back a couple of times, in fact. Right, 12Z, right there. So there's wave number 1. Emerges out of the high latitude flow, which we saw from Alicia's maps. It's isotropic both in the temperature and in the geopotential. I don't know if I have a cross-section right through this time, but if we go to theta and PV, slide up a little bit, and PZ, see where that line is. So we got to come further south. Let's come further south. Watch this feature as it comes down. And then we'll cut it right there. Yeah, so now look at it. It's kept the same complexion. It just looks a little more intense in terms of the baroclinicity. Let's tilt upward on this, Pete. And so here is in green the potential temperature, and in purple the PV, potential vorticity. And maybe if we take theta off, you can really see the conical shape of this PV protrusion from the stratosphere. It's really unusual, and it's kind of small in scale. Of course, there'll be a cyclonic rotation around this thing at this elevation that's really intense. And then if you put theta back on, invariably such features have some sort of baroclinicity underneath them. And you can see right underneath the maximum in PV is the coldest air. And that has to be true in an atmosphere in approximate gradient wind balance. You can't avoid that. And Michael, here's your point about the stability. It's really strong. This would be to the southwest, and it's also fairly strong to the northeast. So the whole underlying troposphere is pretty stably stratified, and this thing's gliding over it, which accounts for the lack of development. I think we didn't really get a strong cyclone. Let's go back to the top. And then let's keep marching forward. We're going to watch a second disturbance come in the flow. Here it comes. And let's take, if we go down to theta prime and PZ prime, I don't remember where I drew the cross-section, but we'll find out when we put it on. Yeah, we'll just go until this baroclinic zone gets along that line. So a couple more times. Right there is perfect. So this thing is, look at it in the white. the isobars at around 5.3 kilometers. That's a really modest little shortwave with a lot of baroclinicity associated with it. Let's tilt that up. My contention here is this is a very different structure, even though it has elements that are the same. If we take theta off just for the time being, you'll see what I mean. So here's an element that's the same. That's sort of a conical protrusion of PV from the stratosphere downward. But it's preceded by an unusually high amplitude ridge. That's that ridge that's breaking upstream that I think is producing or helping to manufacture the environment that can produce this. Then if we put theta on there, much more intense upper level front, but still lower troposphere that's strongly, stably stratified. So this thing's coming across. I'm not going to take the time to show you the vorticity structure. This is the PV structure. The vorticity is also fairly intense, as you might guess. But the vorticity structure is also intense. There's strong PVA by the thermal wind, but it's trying to make this air rise. And that air doesn't want to rise because it's too stably stratified. It took forever for a cyclone to start to develop in response to what was pretty solid forcing generated by this, I think, upper frontal vorticity structure. And so that's what makes the difference between storm 1 and storm 2 is that this thing is a linear vortex strip. It takes time to get itself organized. It also has a real hard time making this air rise in the vertical. The first one came into a slightly more, less stably stratified atmosphere and had a little bit easier time, even though the vortex structure associated with that was of a different quality. So anyway, just a few things at a first glance on what I think was the difference between these two storms. In the end, they get amalgamated and they don't care anymore because it's just a giant vortex structure.
Would you say that the stratification is a bit higher than it typically is either this time of year?
I think so.
Often?
I think it is. That's really unusual. Yeah, it caught my eye immediately. And this is in the aftermath of the first cool down. So we've really brought the atmosphere to a pretty stably stratified state, unusually so, I agree. And there's just no way that it can make the air in the lower boundary layer easily move upwards when that forcing comes along. So it's quite a different environment than you usually get. So anyway, that's what I have for this. So a couple of things of interest. So, I got to give you the microphone now, too.
Pete, I'll start with Kai and then go to pivotal. Thank you, John, for a great opening discussion. I'm going to return to something I haven't done in quite a while, which is looking at sort of our locally run forecast models. And if we go back just one to the original page, this was actually created about 25 years ago this year, or 25 years ago to, around this time of the year, back in the early 2000s. And it was by Darrell Kleist, who's now at NCEP. I think he's the acting assistant director of NCEP, or deputy director at this stage. But he created this. It ran reliably on scripts on computers, but unfortunately the computers that I have don't have the last updated 2003. But imagine that. You start a program and just runs and runs and runs and creates images and all that. So I've tried over the last several weeks to get this up to date, trying to run the MM5, but that's not going to work because of the compilers and all that. So I figured I'd switch it to the WRF. So this page will be updated at some point. Uses Genpack, by the way, but so that's no problem there. But we'll go here, and the reason we do this is just running something local, just to get one experience in running models, but also looking at our own output, and we can do sort of experiments and things of that sort. Right now, it's more used for just weather watch discussions and to create for John's favorite image, which are these meteorograms, which don't exist today. Don't click on that. The meteorograms, that's what they're called. John prefers meteorogram. Any case, we'll click on this time height section. This is from the model run. So in my working of late last night, thinking I got this finally running, right after class, things were running, and then I realized, nope, after it all finished up, this is based on the 6Z run, not the 12Z run. So all the errors you see on this are all mine. Darrell has nothing to do with this. This is my change. But here's our time height section. And I like looking at these because it gives us a sense of what's happening in the vertical. We could also just look at the passage of weather systems rather quickly, succinctly, and then we can go back and look at the horizontal maps that are associated with these fields. So on this particular map is shown in yellow, potential temperature. In green, the dynamic tropopause. This is the potential vorticity. In red is the relative humidity. And not shown on here, and I have to figure out why, it's probably a variable naming issue, would be the vertical motion field as well. And then the winds, of course, are plotted here. Time runs from left to right on this, so you can see the times here. And what you can first note here in terms of the potential vorticity are these sort of undulations. We have this relatively low tropopause over us from this morning into late tonight. Goes up a bit, increases in altitude, comes down just a little bit, but then there's another drop during late afternoon tomorrow. Again, to the extent that this run from 6Z last night still has some credibility. I think it's pretty decent. The other thing that you can see, as we were just talking about before John, as John was wrapping up, was this intense stratification in the middle troposphere. Okay, once you get into the stratosphere, obviously you can expect things to be, and this only goes up to about 250 hectopascal. You expect things to be more stratified, but this is pretty uniformly stratified all the way up, which is really interesting. Except, though, for the boundary layer. And so that's kind of interesting in terms of the weather we're experiencing here at the surface. So you can see the fact that by this afternoon, the models were forecasting a pretty good depth, almost up to 800 millibars, an essentially well-mixed layer in which the potential temperature is nearly uniform with height, indicating neutral stratification. The winds, except when you get very close to the surface, nearly uniform with depth, indicating momentum mixing pretty vigorously in this weakly stratified environment. So the strong winds aloft are able to mix down to the surface, and that's giving us sort of those gusty winds that we're experiencing during the course of the day today. And that fairly stable boundary layer exists throughout the forecast period. It begins to recover a little bit overnight as the ground begins to cool off. You get a few isotropes popping out of the ground, if you will, sort of outcropping, and then we mix out again tomorrow. But the other feature that's here, you can see in terms of the relative humidity, is we keep this greater than 80%, 90% relative humidity over us during this period. That's partly because we have the stratified layer above us that's keeping the air from sort of mixing out. Also, with the passage or the arrival of, and then passage of this weak upper trough that we see here, that's going to be associated with an increase in relative humidity and maybe a chance for a light sprinkle sometime late tomorrow afternoon. So as John was saying, there are a couple things that are at work here with the clouds that we see outside. Obviously, the ground's relatively moist. It's cool. We get any sort of heating. We get sort of cumulus clouds forming. They rise up until we get to that stable layer, and so we keep the clouds there. But the other feature there is also we have these sort of weak impulses, weak upper troughs that are going by. They're helping to accentuate the upward motion. But as we saw in the satellite imagery, this large cyclonic swirl over the central part of North America, upper Midwest into southern Canada, that also is going to be associated with, and this is typical for later in the fall, Ekman convergence at low levels and sort of a gentle rising motion that occurs, not because of dynamical forcing because of these features, but because of frictional convergence in the boundary layer, leading to some very gentle upward motion, which can produce clouds, stratiform clouds, and things like that, hit up against the stratification that you sort of just trapped there. So anytime we get any clearing, things are going to fill right back in terms of cloudiness during the day tomorrow into tomorrow evening. And then after that, as we get into, this will be Sunday, then we see, again, relative humidities are beginning to drop off a little bit. Winds are shifting more to the north over time. So that's kind of the big picture for over us. In terms of precipitation, we're going to see in just a moment that most of the weather systems are going to be passing. Most of the precipitation is going to be very light. The biggest chance up to the north where this trough is a little bit more intense as it goes by. So let's get out of this for a moment, Pete, and I'll show a couple images here and then we're going to go to pivotal because I'm not sure how well these all came out. So if we go to 12 hours in the forecast, Ben Morgan, let's go to pivotal. I'll just stop right now. Okay. So this is valid, and we'll go to, let's change the date to the current time for the forecast. And okay, that's 18Z. Again, you can see on this map, this broad circulation, cyclonic circulation. The light precip here isn't necessarily forced by disturbances in the upper troposphere. I would say very close to the cyclone center to the east. There are a lot of ways we can diagnose why that precipitation is occurring, but I think broadly some of this is the model's representation of very light precipitation due to this Ekman convergence in the boundary layer. We can see this nice sort of cold advection that's over us today, and we'll see this currently, and we'll see how that actually evolves over time. But the weather across the country is going to be rather quiet, I think, for the most part. We see also some precipitation that's out over the central plains. We'll see how that moves toward the east, northeast over the next couple periods. Let's quickly go through this. Let's go to 12 hours forward in the forecast. Okay, so this is by late tonight. This is that first little lobe that goes by where you can see the temperatures a little bit colder over us as this feature goes by. The cyclone slipped it a little bit to the north, but we still have a broad cyclonic curvature over us. And anytime that cyclonic curvature is occurring, that's going to be associated again with a sort of weak frictional convergence in the boundary layer beneath it. We have to see that curvature change to more anticyclonic or neutral before we get rid of any of the Ekman pumping. And the fact that we have moisture, water vapor in the lower troposphere, that's going to help keep the clouds in. Again, relatively quiet. We get this little lobe of, I believe that's a minimum passing by us. If we go ahead 12 hours hence, or let's go to, so 30 hours in the forecast, so tomorrow 18Z, we begin to see the precipitation that was here has moved into the northeast, and we have this area of, I would say, light to moderate rainfall over parts of New York State into southeastern Quebec and parts of southern Ontario, southeastern Ontario. For us, this time, cold advection persists. And in fact, yet one more surge of cold air aloft is about to come down. Again, this is going to destabilize things as well over time and lead to perhaps continuation of the clouds over us, even as the flow is becoming more, less cyclonically curved.
Yeah, it's interesting you say that because that 540 line looks like the threshold line, north and east of which there's scattered precipitation.
Right.
It's like it's cold enough to make it unstable.
Right. So the instability is probably a bigger role here than the curvature, at least at this point, as the main cyclone center is lifted to the north.
Is that the first time the 540 line has entered the US?
Yeah, that could very well be.
Yeah, Superior and Bayfield would be our first readers of it.
Yeah. So let's take a quick look at the precipitation over the northeast. And to do that, I would like to bring temperatures in. Let's go to 850 hectopascal and look at the temperatures and winds. Sorry, further down. Okay, so this is not the most obvious region of frontogenesis, but you can see, if you look right here, along this line that extends from the mid-Atlantic up into north-central Maine, you can see the flow goes from westerly and cold advection to southerly with warm to neutral advection just ahead of it. So this is a band where you'd expect to see convergence occurring at the surface, frontogenesis also occurring. That leads to a transverse circulation along this line, along this region. And with sufficient moisture, you're going to get clouds and precipitation forming along this band. And so I would say it's relatively modest frontogenesis from my eye. But John, I don't know if you have a...
We were talking about that yesterday in 452. The forecast is a little more diminished in that intensity, but it's the exact same thing. Yeah, I think you're right on.
Right. And I think that little vortex that we saw in one of the earlier forecasts that looked like it was pretty robust kind of has faded in this, and we can probably check that out by going to 500 hectopascal of vorticity.
It's a meat grinder. It just strips them all out, makes them all linear.
That's right, and so that's probably more at 850 hectopascal. But the frontogenesis actually extends all the way down into the southeast as well. And so I imagine if there's any water vapor, we can look at that at 700 hectopascals. Let's look at the moisture variables further down on this. Please, Pete. Upper air moisture, we'll go to 700. Okay, yeah, just all ahead of this band. There's the precip, and you can also see where the subsidence is pretty evident. But through this region where there is still frontogenesis occurring at 800 hectopascal, I guess the chance for convective precipitation also beginning to get stirred up along the front is going to be a possibility. But for us, a lot of clouds staying in. This is Saturday. Let's go ahead to 42 hours in the forecast. Okay, so we stay with high relative humidities, but this is again largely because it's cool aloft. It's cool over us, or cool at 700 hectopascal, and there's a bit of water vapor there. But really dry air sort of surrounding this region over the Great Lakes. Let's go back to the surface map, please, Pete. And again, as that last trough goes by, maybe some light precipitation. We saw that little shortwave trough that showed up in the time height section That's it. This is it right here, moving out. And then we just await the passage of this ridge axis over us before we're going to get any warming up. And I want to just go through this really quickly. Let's go to 60 hours in the forecast, please. And this is a relatively quiet period. That anticyclone sort of heads southeast, and we're still, in terms of temperature advection, the warm advection is beginning to start up in the central plains and further to the west, but you'll see here we say dry. Go ahead to 84 hours, please. So this is Tuesday afternoon. The ridge finally is moved further to the east, and that's where that return flow from the Gulf of Mexico, air beginning to move northward. You're going to get a plume of high water vapor moving up through the central plains to our west, but we still have relatively low dew points over us, so it's still comfortable weather even on this day. But things are going to begin warming up. Let's look at temperatures at this time. Okay, so 70s and 80s, that's not too bad. And you can see further over Texas, it's, this is still September into the 90s, but we're doing fairly well here, staying in the 60s. This is, again, it's what, 7 at night, 0Z. It's not the day is not going to be that warm. Great, 108 hours, please. Again, the ridge is just stubborn as it moves, and so the flow is still southerly up through the central plains. But we're going to see heat beginning to really build in the southeastern United States. Let's go to 132, please. Okay. We've finally gotten back into the 70s, and I can't recall exactly how far we had to go into this. We'll go 156 and then go to 168. It's beginning to spread, but we're still staying around 70 or so at this point. If you go 1 to 68, so weather watch time, or the morning for weather watch, another invasion of cool air coming in. And let's go to our time at weather watch would be what, 174, so 18Z, so it's 168 hours from now. Really getting hot here, but we stay relatively pleasant.
That is different than yesterday. That's great. Gives us a little more reprieve.
Right, and we'll look at the surface map just to get a sense of what this looks like. Also, that band right there, I was going to say, precipitation, huge sprawling anticyclone comes down from Canada. Didn't see that through the text right through the as we step through the maps, but that's going to keep us. That could keep us relatively cold, or cool. The one thing though, so as much as I say, yeah, it looks like we're going to get, it'll still stay cool for the next part of next week. Let's look at another model. When you make forecasts, single deterministic forecasts are no longer the name of the game. We'll look at UW-AOS for the same time period. You really want to look at multiple models to get a sense of what's happening. This looks entirely different, or very different, with this anticyclone. We're a little bit warmer, but this anticyclone is further to the east at this same time. So you can see that we're still in the still southerly flow here. If we look at the ICON model, this is the German model, Deutsche Wetterdienst. That's probably closer to the GFS. It has the boundary just right over us, so it looks slightly to the north. So that's going to be relatively warm, but the cold air is not too far away. And what are our temperatures in this particular route?
Oh yeah.
Okay, I think this is because of clouds and precipitation, but that boundary is right over us. And then let's go to the Canadian model, GDPS. And I think we're going to see a very similar solution if we go to the surface map. It's drier. That I perhaps doubt a little bit, but we can see that this boundary is just over us. So this anticyclone coming down from central Canada, just the position of it over the next couple, by the end of the week, could be the difference between us being in the 60s to, if it shifted a little bit further to the east, getting into the mid 70s and some clouds and precipitation. And where this boundary ultimately sets up will determine whether or not we get some precipitation.
Yeah, its geometry is different too in these solutions. This one's almost circular in the GFS.
It's broader, right?
Yeah,
So,
sitting on top of us.
and I think that speaks to the fact that the forecasts have changed a little bit. If we go back to the GFS for just a moment, please, Pete. I really should watch the time. One of the interesting things is we look at other forecasts valid at the same time. So we can go up here to runs. Let's go a day ago. Anticyclone here, it's a little bit further to the south, but we're still in the sort of cooler, relatively cooler weather. Let's go another day back. That looked kind of the same. So there's been a sort of a forecast fracture. We've had this anticyclone kind of over us, and now more runs are putting it further to the north and keeping us a little bit cooler. So that's something we want to look at. Final thing I want to say, tropics are relatively quiet. The Hurricane Center is watching a disturbance well to the east of the Lesser Antilles, and they're telling people in that region of the world to sort of keep watch over the next, into next week, as that might approach the islands and as it begins to develop. But mid-latitude weather is interesting, so we'll just keep focused on that for now. I'm joking. Yes. Get rid of that. Okay, anyway, thank you, John, again, for a really great presentation. Thank you, Pete, for all your help in getting this together and getting the maps and everything up. And also the audience here, please ask questions. Please continue to be engaged in this, and looking forward to a great year. Thank you.
All right, thank you.
Oh, one more thing. For those of you that are watching online, certainly hit like and subscribe. I want to do that once.